Hi mathematicians, we have made it to section 2.5 and here we're going to talk about the limit as x approaches infinity or the limit as x approaches negative infinity of some function f of x. And if either of these are true, it can be said that there is a horizontal asymptote. Right before we had a vertical asymptote. Here we're going to have a horizontal asymptote at y equals L. Okay? And so let's go ahead and look at some examples. So let's go ahead and look at the limit of x squared as x approaches infinity. So if we just look at this graphically, this is a function we're all very familiar with. Symmetric about the y-axis. F of x equals x squared, smush it in there, okay? And so as we go in this direction, as x approaches infinity here, where does our output go? Right? Our output is just going to keep crawling up and up and up and up and up and up and up forever and ever and ever. And so when we finally get to infinity way out here, which is never, right? But we're traveling forever way out here, where's our output going to be? It's going to be at infinity. Okay, let's go ahead and look at another one. Let's look at the limit of 1 over x as x approaches infinity. So we know that the graph of this looks like this. And we can visually see that as x gets larger and larger and larger, we get closer and closer and closer and closer and closer to 0. We just never quite get there, right? We stay to this side, we stay above the x-axis forever, but we are going to get 0 here. All right, so the limit as x approaches infinity of 1 over x is 0. Let's go ahead and look at the limit as x approaches negative infinity of 1 over x. And so we know that that graph looks something, well, 1 over x, I'm just finishing it, right? I ignored this left-hand side, but graph of 1 over x has this guy over here and this guy over here. And so as we can see graphically, as we travel down the x-axis towards negative infinity, this is going to become closer and closer and closer and closer and closer to the x-axis, but never quite touch it. Okay, so the limit there is also going to be 0. Let's go ahead and do another one. Let me see if I can raise this up and refocus. Looks not that bad. So we have the limit as x approaches negative infinity of 2 plus 10 over x squared. And then we're going to look at the limit as x approaches positive infinity of 5 plus sine x over square root of x. Okay, so limit as x approaches negative infinity of 2 plus 10 over x squared. So let's go ahead and just plug this in. What do we get? We get 2 plus 10 over negative infinity. All right, what is that going to end up being? This value here is going to go towards 0. Right? So we have any value on the top. We have a really big and negative number on the bottom. This is going to be a really small negative number, right? We're talking about a 2 plus a point negative, right? Point 1, right? But smaller than that. But so where are we going as we get to this negative infinity? The limit, we're going to end up getting very close to 2. So the limit, as x approaches negative infinity, equals 2. Okay, just 2, not this other stuff. Let's go ahead and look at this one over here. Same kind of idea. We have the limit as x approaches infinity of 5 plus sine x over square root of x. So I'm going to get 5 plus sine infinity over the square root of infinity. What do I know about this? I know its max is plus 1. I know its min is minus 1. And I know it's just going to oscillate in between those two values. Right? So you have a value like 1 or minus 1 or 0 on the top, or something in between. And then on the bottom you have the square root of infinity. Guess what the square root of infinity is? It's infinity, right? So we have the limit as x approaches infinity of 5 plus largest this thing can be is 1 on the top over infinity. Again, we're with 5 plus 0. Okay, so this is going to just go towards 5. Okay, do you see those there? So sometimes you have to kind of think about, you know, what can these be and where are they going? Let's see. I'm going to tell you some laws here, some general rules about infinity as x approaches infinity and doing the limits, and then I'm going to end this video and start another one to do a couple more examples. Yeah, we'll start another one to do end behavior, but let's go ahead. So we have limits at infinity of powers and polynomials. And so the limit as x approaches infinity of x to the n equals infinity all the time. The limit as x approaches negative infinity of x to the n equals infinity when n is even, negative infinity when n is odd. That makes sense, right? I think I got that one. That's true. Yeah, I don't know. I like how they wrote that. I don't like how they split these up in the book, or they split them up a little different, but that's fine. Just know, obviously, if we're going to a positive number, it doesn't matter if n is even or odd, you're still going to get a positive infinity out. When I have a negative infinity here, if this is even like a square or a 4, right, the two negatives are going to cancel. But if this is an odd, you're always going to end up with one more negative value. So that's going to be true. Okay? So this whole thing is going to equal negative infinity when n is odd. Equals infinity when n is even. Okay, just so you understand what we're writing there. All right, number 3, we have the limit as x approaches infinity of 1 over x to the n equals the limit x goes to infinity. And this can be plus or minus. And that equals 0. Right, and that makes sense. Right, 1 over negative infinity, 1 over positive infinity. It doesn't matter. Both of them are going to 0. And then we have one more. The limit as x goes to positive or negative infinity of p of the x equals the limit as x goes to p of x. What is p of x? P of x is a polynomial with the form an. Does this make sense? I'm just going to write this notation and actually talk about it in a second. Okay, so I'm going to finish this and then I'm going to go back to this. So this is a polynomial. So we have a polynomial. X again is going to positive or negative infinity. And so depending on the sign or whatever, what's going on, you're either going to get an answer or positive or negative infinity. So these are just some general thoughts, right? And I think they're all pretty intuitive. Obviously, if I raise infinity to anything, I'm still getting infinity, okay? Even if that's a fraction, right? The square root of infinity is still infinity. The cubed root of infinity is still infinity. Okay. Limit as x goes to negative infinity of x to the n equals infinity when n is even. I'm going to write equals negative infinity when n is odd. The limit as x goes to plus or minus infinity of 1 over x to the n, right, is going to equal 0. There. Do a better job with that. Makes sense. This is the limit of any polynomial is going to either be positive or negative infinity, basically. All right. And so I just want to look at this notation for p of an x as a polynomial real quick, because it's something you're going to see later on in your math career. So I would say that p of x is equal to this an x to the n plus an minus 1 x to the n minus 1. And all this is saying is that you have, this is your leading term. Right? And this is your last term, just your just the number, if you have it, right? So if I go ahead with a polynomial and say 3x to the 3 plus 2x squared minus 6x minus 4, this 2 would be this a2, right? This negative 6 is this a1. This negative 4 is this a0. And then in this situation, the leading term, this n would be 3, and the a to the n would be 3. Okay, so this notation is just a way to say a polynomial. All right? Okay. So I'm going to end this video because it's getting a little long. And then I'm going to start a new video and talk about end behavior.